So good evening, everyone, and a very warm welcome to all of you for joining us for today's webinar, which is titled UDA Framework-Based Sediment Management in the Tropical Waters of the Indo-Pacific Strategic Space. My name is Nishtha, and I head the Communications and Outreach team at the Maritime Research Center. And I'm going to be your host and moderator for this webinar, which we are jointly organizing with Needhwani Technology Private Limited. On behalf of my team, I'd like to thank all our distinguished speakers, panel members, and participants for joining us today. So just to set the context, I'd like to say that, sediment may appear to be slow-moving, almost invisible force, but in reality, it shapes our coastline, impacts the maritime infrastructure, influences ecosystem, and increasingly determines the resilience of our coastal economies in the face of climate change. Today's discussion brings together science, technology, policy, and strategy within the broader framework of underwater domain awareness to explore how we can move from reactive sediment management to predictive data-driven decision-making. A gentle request to the audience, please keep your microphones muted while the speakers address you. For any questions or comments, kindly use the chat box to keep the session interactive and engaging. To set the context for this important conversation, may I please invite our convener, the convener of this event, Dr. Commander Arnab Das, who's going to deliver the opening remarks. Before he does that, I'd like to introduce Dr. Das. So he's a researcher, maritime strategist, and an entrepreneur. He's the founder and director of the Maritime Research Center, an organization, a think tank, which is working on a unique concept of underwater domain awareness. Dr. Das has served in the Indian Navy for over 2 decades. He earned his master's and PhD from IIT Delhi while serving as a uniformed officer, and he undertook several research and development projects during his 7 years tenure at the IIT. After retiring from the Indian Navy, he worked at the Acoustic Research Laboratory at the National University of Singapore. I'd hand it over to Dr. Das for his opening remarks.
Thank you, Nishtha. First of all, I must thank our esteemed panelists today. Admiral Arora, sir, thank you very much for joining us. Your participation brings a very new dimension, apart from being the chief hydrographer in the Indian Navy, which almost more than close to 4 decades. You have seen this aspect very closely, and you reached right up to the top of the leadership ladder to manage this at the policy level. And now I know you are more busy, probably post-retirement, looking at various other aspects of global geopolitical aspects. So thank you so much, sir, for joining us. I would also thank Rear Admiral Jayaratne, sir, Chief Hydrographer from Sri Lanka. It's very important for us to get a perspective, particularly Sri Lanka with its unique geography, and also Sri Lanka has 7.8 times more sea area than the land area. So definitely this is a very, very important discussion. And sir, your joining will definitely add a new dimension to this. Chandrasekhar, sir, thank you very much for joining us. Your perspective from a think tank's perspective, plus you have been in the defense ministry for a very long time as a bureaucrat, so you understand policy making at a very different level, and now for quite some time you have been associated with multiple social causes. So we are trying to present a dimension which has got very different, a very broader perspective where multiple stakeholders are being kind of brought together. Amit ji, thank you very much for joining us. Your perspective will be very, very important. You have been in the research and think tank circuit for a very long time. You understand the water diplomacy very well. You understand the water policy very well. So your perspective will be extremely critical for us. We are awaiting Ambassador Mudgal, sir, to join us. He has been our mentor and he has been guiding us on various aspects. We could not have our participant from Bangladesh for some reason, but we are extremely grateful to all the participants, all the panelists for joining us. I'll make a very quick presentation, although it is not my day today. It's more our research fellow who's working on this. So I'll be covering very quickly on what is the larger framework, and I also want to submit here that this is a series of presentations that Maritime Research Center and Nirdhwani are progressing. This is our research fellows who are presenting their work. We've already had 3 such presentations earlier, starting with the Brahmaputra. We have a dedicated fellow working on the Brahmaputra, looking at multiple aspects, and that particular research fellow is supported by specific domain experts, and she's an anthropology student who made a presentation in January. Then we had one presentation on biofouling, which again, all of you will admit, it's a very important area, particularly in the tropical waters. We have some serious work on biofouling also. And the third was on the fisheries and aquaculture. We had 2 of our research fellows who presented their work, and each one of them, we had participants from multiple geographical locations. I mean, not just in India, but beyond. So we got perspectives, and we have tried to kind of balance it to get panelists from academia, think tanks, domain experts, practitioners, diplomats, bureaucrats, so that we get a very broader perspective. And this is our work on sediment management. There will be more that will be discussed. Quickly, I want to bring to your notice that what we are dealing with is very unique tropical characteristics. One is the rich biodiversity. So ruthless dredging, which has now become a norm, can have a very serious impact on sustainability and climate change. So we need to look at that in a very, very serious way. High population density, so the socio-political, socio-economic, and socio-cultural dimensions become very, very different. And there are so much of undersea resources that are available. So we need to be very careful. You need to use a lot of science and technology and a lot of awareness. I mean, very, very specific, precise awareness. And also we have had a significant civilization legacy. Can we weave it into our modern science and technology or modern understanding so that it can be taken up in a more sustainable and in a more optimal manner? And also this part of the world faces significant young population, aspiring population who require career opportunities. So what kind of career opportunities? Economic growth, of course. So how do we take it forward with that aspect behind? But the challenges are also no less. I mean, the tropical waters, the sonar, which is the basic element for underwater domain awareness, suffers 60% degradation. So how do we make sure? And also there is very little data. I mean, the situational awareness is very, very poor. Our local understanding of the region is quite inadequate, I would say. So there is a lot of work to be done there. So that's where we see an opportunity, and we would like to kind of contribute in that manner. And so this is the larger framework that we are progressing, the underwater domain awareness framework. The biggest challenge, I think, is the fragmentation among the various stakeholders. If you look at it, the strategic security, both internal and external security agencies would require a significant navigability in these waters, and their involvement in now energy security, food security, so many aspects are there. They may not be directly involved, but I mean, in critical cases, their involvement will be required. So their awareness on these will be also important. The second is blue economy. That's a huge area. Multiple aspects are part of it. I don't want to go into the details. Sustainability and climate change and digital transformation. So all these 4 stakeholders are very important, but it is important for us to understand that unless all these stakeholders come together and work together, they will not be able to get an optimum way ahead. And that's very, very important to make sure that we are able to build pooling of resources and synergizing of effort. And the core, as you know, will remain the acoustic capacity and capability building. So we need to work on this very, very carefully. And also, want you see the smaller cubes represent the different problems that we need to solve in this whole thing. So and also it has to be a multidisciplinary approach, sensing, analysis, and then policy. I mean, typically we have a top-down approach where we not only buy the technology from outside, but we also ask them how to deploy it. Whereas we know that there is a 60% gap. So there is a lot more to be discussed here. So my colleague Romit will be taking this forward from there. The UDA framework, as we looks at policy intervention, technology intervention, and capacity and capability building. So we need to look at this in a very, very holistic manner. And technology will be one of the drivers, but we cannot ignore the traditional knowledge that is important. So there will be a little bit of elaboration on this aspect also through Romit's presentation. So this is a very specific case on sediment management where there are multiple stakeholders. Freshwater management is another very important area. Inland water transport is even coastal navigation is part of that. And then deployments across water bodies, whether it is for defense or for any other purpose. This is the digital platform that we have created, or digital framework, the marine spatial planning. So you can see a spatial temporal map. This will be a very, very useful tool for our policy makers. If you can get the data into a spatial temporal map, which is now being pushed by the UNESCO as a marine spatial planning. I mean, this will be a very important governance tool for all of us. And we are trying to work on multiple dimensions of this, not just for sediment management, even how to deploy sonars, how to look at fisheries, aquaculture, how to look at mineral resources. So if we get a heat map like this, there'll be multiple decision makings that will become far more easier and far more precise. One important aspect is, if we just take the case of India, 3.7 million square kilometers of EEZ that we are talking about. It's not possible for us to put so many sensors. And when we use sensors, then what kind of resolution can we get? So modeling and simulation is the best method way forward. And this can give you infinite resolution and infinite area coverage. So using above water data, we build the models. Using acoustic methods, we validate those models. And once those models are validated, now AI and various such technologies can give you a very different dimensions of how to manage these things. So my colleague will definitely elaborate on this. And here we can also take care of the specific tropical dimension. To see, to understand, and to share is the broad acoustic capacity building. To see is the hardware, whether it is a sensor and also the platform, whether it is a AUV or a surface craft or a submarine, whatever. So that is one part, that is the hardware. But once that data is collected, then the analysis becomes very important. So to see, to expedite or to accelerate our development, we can definitely import the hardware. But the analysis cannot be offloaded to anybody. Otherwise, we will be sharing. I mean, this 60% degradation of performance that I say about sonars, if we can deny, this to our adversary, we can get double advantage strategically. So by whatever improvement we can do because of our data analysis, there are different methods. We won't have the time to discuss that. But data analysis has to be, and if we share this data with anybody outside, which may get into the hands of our adversary, this can become very catastrophic. So we need to keep the data processing within our domain. And the third is to share. Now, to share is very important. It has to be customized. Now, to a very senior naval commander or to a very senior decision maker, they may have the liberty of a big screen, but they will need very strategic inputs. They cannot be overwhelmed with very basic tactical data. So very customized displays need to be provided. But at a ground level, whether it is a fisherman or a ground level Navy sailor, they need tactical data. So and they may not have the luxury of a big screen. So a mobile app may have to be designed. So there are nuances in the to share part also. So we are trying to work on various such aspects and make it. I mean, sometimes we look at startups and they say we've made an AUV or we've made a drone. But in the absence of the ecosystem, this will make no sense if we can't So we have been pushing for solutions rather than selling products. So, I mean, there is enough hardware which can be configured to provide solutions which are local. In terms of the manpower, we need high-end data analysts who will take care of the entire computational and also the hardware aspects. But once that information is brought in, we need domain specialists who will kind of make sense of that data or make sense of that information and give us the policy support. But the third is more interesting for me, the field deployment specialist. We need to still send people for waterfront deployments, whether it is for collecting sample or putting sensors or even for other information collection. They can be the coastal communities or the riverine communities who are very comfortable with the waterfront. In fact, the deployments, and this is where the traditional knowledge can become very, very important. We can weave in this entire thing and they can be part of the larger digital transformation that we are looking at. So we've been working on, in fact, Nishtha is herself working on this 100 coastal or warriors or river warriors or even water warriors. So each of these aspects will have their own dimensions and this can be covered. So, and also when we look at any kind of projects we need to look at or any kind of policy formation, people, economy, nature, I mean, the livelihood aspects, the economy, of course, and nature, the sustainability dimension needs to be looked at, and it has to kind of be balanced and taken forward together. But with a better underwater domain awareness, I think it will be much easier for us to push this. MRC has been working on this. We have, I think, put at least 20, 25 interns from the top IITs and even from the liberal arts institutes like St. Stephen's and others who have worked and kind of built our work from behind. And also then we have had at least 3 to 4 fellows, including one PhD scholar who has finished her work on this particular aspect. So we are quite, I mean, it's, I think, more than 6 years of work, which now Romit is progressing. But we keep on adding various, and every year when we have interns, they add to multiple dimensions and their work gets accumulated into this entire thing. We have got skilling programs approved by the Maharashtra Skill University, and also now NCVT clearance is being provided to us. So we'll be running such courses. And also University of Bombay is also considering approving them so that we can run them as proper academic and skilling programs. And we have been training various stakeholders like Border Security Force and Disaster Relief Force and all these, even Indian Forest Service officers, even Indian Foreign Service officers also, and Armed Forces officers are being trained on various such nuances, because even army officers are facing a lot of sediment challenges in terms of navigating the river system. And then the real world problem solving, I think my colleague will be discussing in more details. So thank you so much. Back to you.
Thank you, sir. Thank you so much for those illuminating opening remarks and for framing the importance of integrated approaches in the maritime governance. We now move to the core of today's session, the technical and the analytical foundations of the UDA-based sediment management framework. It is my pleasure to invite Romit Kavre, who's a research fellow at MRC. A little bit introduction about Romit. He is a graduate of IIT Delhi, who has a degree in civil engineering. He's currently pursuing his PhD in geotechnical engineering at IIT Delhi. He's also a research fellow at MRC, and his primary focus is on sediment management in the tropical waters of the Pacific. His work highlights the importance of sediment management across domains such as coastal zones, freshwater systems, and watershed management, while discussing the impacts of sedimentation in context to people, economy, nature. I hand it over to Romit to make his presentation for today.
Good afternoon, everyone. I am Romit Kavre, and I've been working on this aspect of sediment management within the tropical waters for over 2 years now. So we'll have a discussion more about what work we do pertaining to the sediment management. I'll start with a general introduction first. So we see that the Indian Ocean region is a very contested region today, especially within the current with the current scenarios of what we have seen in the Strait of Hormuz. And also we know that a lot of oil shipping lane, more than 60 to 70% of the global oil passes through this Indian Ocean region. So we see that there is a lot of interest of the major global players within the Indian Ocean region. There have been a lot of activity of the Chinese as well, surveying the seabed in the Indian Ocean region. So it poses a very geostrategic importance. Now, being so much of geostrategic importance and being the third largest ocean, it still remains one of the least surveyed and least sampled oceans. Primarily because again, most of the Indian Ocean region countries are low to low middle GDP income countries. So again, most of the ocean exploration requires a lot of funding, and such kind of oceanic exploration equipments and vessels are required. Again, being the least studied and understanding how the various vessel movement, the shipping movement affects the sediment transport, or how the seabed is dynamically changing with all of the oceanic conditions, it becomes very much crucial. especially when I talk about the Indian condition, we have very paradoxical situation when we talk about the sediment related challenges. So every monsoon, we have a lot of flooding in an rivers as well. We have the Ganga Brahmaputra river system, which carry about 1 billion tons of sediment into the Bay of Bengal annually. Now, this brings in a lot of sediment flux within the Bay of Bengal into our coast. Now, another challenge is that these sediments also originate from the right up from the Himalayan mountain ranges. Now, while these flow right from the Himalayan through the Gangetic Plain and enter a Bay of Bengal, they might also get trapped in some dams, in some reservoirs as well. In fact, a recent study by ISER Bhopal tells that many of our aging dams face a very issue of storage reduction, and saying that some of our reservoirs might have actually 30% of reduction in storage capacity due to this excessive sedimentation. They also trap sediment. So at one place we have excessive sediment coming into our coast. At another place they are getting trapped within our reservoirs as well. So we have to look into the various nuances of how that sediment flow and that sediment entrapment is occurring. As you can see in this schematic as well, the thickness of this sediment within the Bay of Bengal region is one of the highest in the world. So it poses a very high sediment flux into the Bay of Bengal or into the Indian Ocean, which requires us to have a very unique understanding of what the local conditions are there. From this context, what we are trying to see is understanding how the sediment flow is happening, or how are we going to manage the sediment. That is looking how the source of the sediment, what is the source of the sediment, and based on what factor it is going to move, it is going to accumulate or get deposited in the various river system, coastal systems, or the marine ecosystems. And especially these need to be understood within our very unique dynamic tropical conditions, so that we are able to come up with some region specific solutions. So this is where we talk about the UDA driven sediment management. So in the UDA driven sediment management, we mostly talk about how we could have this data driven decision support, where we could have data from multiple sources, the hydrodynamic data, in situ measurements, the acoustic data, satellite data. So I'll talk about more of this later on, but how we can integrate the data from the multiple sources. And once we have that integrated data collection, proper data analysis has been done, how that can actually help us in making proactive sediment management plans rather than having reactive measures itself. When I talk about the sediment management, it becomes very crucial to understand what are the tropical challenges. So the first is that the Indian Ocean region, or the Indian subcontinent itself, it has very high sediment load. A lot of sediment is getting deposited from the Ganga Brahmaputra river system itself. Uh, in the meanwhile, the various natural and the anthropogenic activities as well. So we have if there might be rampant deforestation or rise in agriculture, how that land use pattern changes the amount of sediment that actually goes into the freshwater systems. That leads to a change in the sediment load as well. How that sediment load then transports right from the starting from the mountain ranges into the Gangetic plains, how the Gangetic plains are affected by that sediment flow, and then what are the different kinds of sediment within that flow regime that needs to be crucially understood. Apart from that, we also have a very rich biodiversity within the Indian Ocean region as well. So we need to look into how that changing sediment pattern and the constituent of the sediment affect the diversity as well. At the same time, we also need to look into how these biological activities also affect the various acoustic signatures that are very crucial in the acoustic based sediment classification. So there could be biological noise from this various kind of benthic ecosystem as well. Then apart from that, we all know that the Indian Ocean region is a very major shipping lane. It has a lot of anthropogenic activities of continuous shipping, dredging, trawling. So again, how those activities affect the sediment transport, or what are the effects of, say, the vessel movement or the propeller movement on the actual sediment deposition patterns. This needs to be understood so that we are able to look into holistic pictures. Moreover, the noise, the acoustic noise from the various of propellers, like also reduces the signal to noise ratio as well. So again, it has effects on the acoustic part as well. Now, when I talk about the acoustic sediment classification itself, we also need to look into that this Indian Ocean region exhibits strong diurnal and seasonal temperature and salinity gradients as well. Now, uh, this gradient again not only affects the speed of sound, which is very much crucial for the acoustic propagation, which is required for the sonar working for the bathymetry related applications. One of the major challenges is that the tropical condition or the tropical waters behave as acoustically shallow. Now, what I mean by acoustically shallow is that the SOFAR channel depth. So the SOFAR channel is a channel which leads to very slow speed of sound and a long range acoustic propagation. Now, this SOFAR channel within the tropical conditions might range from depths of 2000 meter to 3000 meter, while the uh, while say in other regions the normal range is around 1000 meter, or it ranges up to 50 meters at the poles. So you see, even we, in order to have that large long range acoustic propagation, we need a further more depth than as compared to other regions. Now, our own sonar systems might not be capable to actually go up to that deep layers, again limiting the proper propagation of acoustic communication. So here also we can see that that the sea surface conditions of temperature and salinity vary a lot, especially when we talk about the sea surface salinity between the Bay of Bengal and the Arabian Sea. We can see a stark difference. Now, this might be accounted due to a lot of freshwater river systems are getting uh, uh, they deposit their own freshwaters within the Bay of Bengal, the eastern flowing rivers. So that might lead to a decrease in salinity there. But we need to really consider how this change is happening within our own uh, uh, environment, within our very own environment, how these local changes affect. Uh, Another major is the species distribution. So as I mentioned, we have a lot of coral reefs, the marine protected areas within the Indian Ocean region. How the sediment flow or the sediment type affects the benthic ecosystem in all, what are the different if any vessel movement is there, how that affects the sediment flow, and that might lead to redistribution of some pollutants or of some of the marine debris that might affect the benthic ecosystem. So all of this needs to be properly understood, of how the benthic ecosystem, the environment, the anthropogenic activities, all of them are tied together, and that's why we are looking to study all of them. And one of the major part that we need to look into is that the Indian Ocean region countries, uh, they host around 30 to 35% of the global population, and it's a very young demographic. But we see that they lie in the low to low middle income profile. So we, again, a lot of money can't be put into the oceanic research and development. So we can't just have very expensive solutions imported from, say, the Western economies, and that can be used directly. So we need to develop some region-specific, scalable, adaptable, and affordable solutions that might also leverage uh, human the human resource within the region itself. So what happens when we actually have some of the sonars which are mostly being imported from the more advanced economies. Now, when they are calibrated within their own conditions. Now, when such equipment is being brought and deployed within their own Indian the tropical conditions, there might be added the propagational variability of the sound signal due to the anthropogenic noise, due to the biological noise itself. So that noise interference affects the signal to noise ratio, and then deploying them, calibrating them, and maintaining them poses more of the logistical and technological challenges as well, when they are not properly maintained, and due to the high or due to the larger depth of the SOFAR channel as well, to overall uh, the overall efficiency of the sonar systems effectively reduces to just 60 to 70%. So we have to pay more for the solutions with, and we are getting in return very less efficiency as well. Now this gives us a very good background to basically understand what our local conditions are, and then based on them we can come up with our own technology, our own technological solutions, so that we can improve the efficiency. So this is where we study the sediment management. So what we have done is we have divided sediment management into two different dimensions. So the first dimension talks about sediment transport, where we look into the transport of the sediment across various domains of, say, rivers, oceans, and reservoirs. And then the other is the sediment classification, where we look into how that sediment classification has applications. I'll explain a bit more later on. And then these are mostly considered within the coastal zones and the freshwater systems. Now, why we are looking differently for the coastal zones and the freshwater systems is because of the differences that lead to the sediment transport and other depositional mechanisms. So in the coastal systems, the driving forces of that sediment would be waves, tides, currents, or any kinds of cyclones that might lead to the very extensive sediment transport. Now this leads to a lot of littoral drift and might affect the shoreline erosion. Ports, the navigational channels might be affected. So we have to look at sediment management from a totally different perspective, talking about the coastal erosion or what would be the navigational related challenges there. In case of freshwaters, we are mostly talking about how the river flow or the river discharge actually or the rainfall actually affects the transport of the sediment. So we are mostly concerned with the bed load concentration or the suspended load concentration. We look into how the riverbed morphology affects, or riverbed morphology or the discharge or the flow velocity or the turbulence affects the sediment transport. Here we are mostly concerned with the sediment or the sediment management within the dams, the reservoirs, or the inland water systems as well, facing challenges of excessive siltation, storage loss, and urban flooding itself. So the coastal zones and the freshwater systems, they both have very unique condition that needs to be separately studied. Now when we talk about the sediment, what is the role of sediment itself, the sediment characteristics, how do they affect the transportation and classification itself? With this again, the sediment transport and is governed by the sediment classification itself. So we could have different kinds of sediment: clay, silt, sand. They might again vary with the texture as well, their roughness, what would be the cohesiveness. There might be some more cohesive sediments, there might be cohesionless sediments. So these characteristics, these mechanical properties actually define how this sediments may be transported across the uh, uh, across the fluid medium itself. How the hydrodynamic conditions and the sediment properties are actually interconnected with each other. We might be able to get it from the sediment classification itself. As we can see, the cohesive sediments, they might be able to flocculate together and they may settle earlier, while the cohesionless or the coarser sediments might flow over through larger distances, and then they might settle down say near the inlets of the estuaries or further on. So again, sediment characteristics play a very crucial role, this requiring proper sediment classification. Now, when I talk about the two new one or the two dimension of sediment management, the first one is the sediment transport modeling, where what we actually do is we take in the various input data parameters, like what is the sediment type, what are the flow conditions of the river flow conditions, like velocity, the discharge, what are the sediment properties, what are the bed conditions, the bed roughness or the slope, and what are the various different boundary conditions there. And then we try to solve some physics based equations, like the Navier-Stokes equations are there, some FEM through some FEM or FDM methods, so that what we are able to do is, given the input conditions, we are able to predict or we are able to model how the sediment transport flow would look like. We could have certain dynamic heat maps of where would the sediment where would be the excessive sedimentation happening, or where are the shoaling happening. Now, to model this, there are a lot of commercial softwares also available, like the HECRAS or Delft 3D is there, through which we can model the sediment transport. right now we can also leverage the machine learning and AI based techniques to actually model sediment in case of the lack of proper data. This is what we are also looking into. The second aspect is the sediment classification. So in sediment classification, we have to generally what we do, conventional methods actually require you to go to the particular location, pull out some grab samples, and then do extensive laboratory tests to find out what are the mechanical properties or the chemical properties. What other approaches can be is to have the satellite based sediment classification or the suspended sediment concentration mapping. uh, to the various satellite systems like the Sentinel or the Landsat satellites, we can extract the satellite imagery or the spectral data. Now there are various empirical relationships also developed through which we can relate the various spectral data to the suspended sediment concentration or to the turbidity. Uh, a lot of spectral indices are being developed to actually map this satellite information to the suspended sediment concentration. So it provides a very macro range, as we can go over from a very large spatio-temporal range to actually classify the sediment with varying timescales as well. The another technique would be the acoustic sediment classification. So here we would have the different acoustics, like the various sonar systems like the multi-beam echo sounders, a sub-bottom profiler, or the side scan sonar. And then by choosing a particular frequency, we can actually try to gather the backscatter data. Now once we have the backscatter data of the various set of the seabed, we can try to have proper data analytics on or analysis on them, so that we are able to actually extract meaningful information from them, creating sediment type. So I'll explain what would be the different methods for this acoustic sediment classification in the end. But these are the two major techniques that can be leveraged to have a large spatio-temporal sediment classification itself. Now, when I talk about the sediment transport or the sediment classification, we really need to look into where all of this, the practical applications might go into. So one of the major challenge that the Indian coast face is shoreline erosion. So around 40% of the coast face erosion of some sort, mostly in Kerala, Gujarat, Tamil Nadu, West Bengal as well. So with how the changing hydrodynamic condition leads to the shoreline or leads to erosion and accretion of the sediments. Now once that erosion and accretion happens, how that sediment gets redeposited, if say there is a nearby port, how that shoreline erosion affects the breakwaters, how it affects the foundation of the birds, or if that sediment is redistributed to the navigational channels, or how is that sediment is getting redistributed into that navigational channels. So we need to have these studies of how the shoreline, what are the sources of sediment there, how the sediment is getting redistributed to the various natural forces as well. Now say such sediment goes on depositing into the navigational channels of the ports, and it remains unchecked for a longer period of time, as you can see in the video graphic as well. If it goes unchecked, it might clog the navigational channel itself, uh, thereby reducing the thereby reducing the available draft for the larger vessels and reducing the operational efficiency of the ports itself. So what's the a conventional solution? Dredging is one of the most conventional solution that they have taken up for sediment removal. However, we must acknowledge the fact that dredging is not a react, or it's not a very should not be a short-term solution itself. We need to look into long-term solutions of how are we going to actually reduce the sediment supply itself. Also, when I talk about dredging, how we do not have the understanding of the local sediment dynamics. Say if we have done dredging over a particular navigational channel, how are we actually mapping the pre and the post dredge volumes? So there is no proper compliance of the dredging volumes itself, and how that dredging affects the seabed, the benthic ecosystem. Again, understanding how the sediment transport might happen, or how the sediment flow change due to the dredging itself affect the benthic ecosystem, leading to a more extensive environmental impact assessment can be added. Now here our sediment transport modeling and our predictive modeling can actually help. So if we are able to identify what are the various sources of sediment in cases of extreme hydrodynamic condition, in cases of extreme flooding or cyclone events, how the sediment flow might happen. If we are able to create a digital twin of the port itself and then model the sediment flow changes for different conditions, we might get hotspots. So and then we can go into the particular hotspots and then take up uh, uh, solutions for that region itself. So what we are trying to do is going from a macro scale to a micro scale response. Now, as I mentioned, the dredging operations are being extensively used. In fact, when setting up a new port, 30% of the cost can be taken up for the dredging itself. But if we are not able to manage this, what is the dredged amount, or we are not able to quantify the dredged amount, it leads to a lot of operational inefficiencies as well. Because if we go over dredging, it might have issues with the seabed, the benthic ecosystem as well, leading to a lot the environmental impact as well. If there is under dredging, then we might need to do repetitive dredging, again leading to higher cost itself. So it's a very inefficient method of monitoring the dead sediments. At the same time, when the sediments are getting redistributed, they might release some of the toxicants and also lead to an increased turbidity. Now, this increased turbidity might affect the sunlight transfer or propagation within the lower regions of the seabed itself. Now, uh, when such sunlight is hindered from entering the seabed itself, it might lead to eutrophication as well, leading to some dead zones within the water bodies itself. Not only coast, but when we talk about reservoirs in case of large water bodies itself. So if we are not properly able to link the amount of dredging with the environmental impacts, or even if such dead zones are created, it might affect the overall livelihood of the fishermen or of the coastal communities which live near the coasts. So it not only has environmental impacts but also the socio-economic impacts as well. So we really need to look into the coupling of the people, the economy, and the nature all together when we are talking about the sediment management. Now, again, this sediment management has importance in the inland water transport as well. So, in order to have proper navigable waterways throughout the year, we need to have some certain draft over the year. Now, excessive sediment supply from various sources, or say from floods, or if water is released through the dams, how that affects the sediment supply. That needs to be really looked into. So when I talk about this sediment trapment by the various reservoirs, we are concerned with the watershed management. Now, what might happen is that a lot of large reservoirs or dams on the river systems might entrap these sediments. Now, this entrapment leads to the storage capacity, but it also can endanger the structural stability of the dam itself. Uh, in fact, the most of this entrapped sediment, if that is getting redistributed, it affects the water quality as well. Now, if that sediment contains some metal pollutants or some heavy metals, how that affects the water quality and the benthic health. Now, this might also affect the human health as well. So it has far reaching consequences, just rather than just the turbidity. So we really need to look into that environmental impact. And also, if the dams are entrapping the sediments at the upstream, they lead to uh, uh, sediment starvation downstream. So how that sediment starvation downstream is affecting the downstream morphodynamics or the downstream aquatic systems, again. So this also needs to be properly understood. Now, one of the I'll talk about one of the cases that disasters that happened. So this was in the 1980s in the Lake Pegner. So they were doing some oil drilling was done within the lake itself, and one of the drilling actually penetrated a salt dome. So there was an salt mine underneath, and it penetrated a salt mine, which led to a catastrophic creation of whirlpool, and all of the freshwater lake drained into that salt mine itself. Now, interestingly, the fresh water from the lake was drained and it was replaced by the salt water from the Gulf of Mexico. So you see that not knowing what lies beneath the surface, beneath the seabed, it costed the change in the ecosystem from the freshwater to the marine to the saltwater ecosystem, affecting the aquatic ecosystem there and the nearby ecosystem as well. So that's where we are laying emphasis on the seabed mapping itself. So within the complex or the rugged terrain or the rugged bathymetry of the Indian Ocean region, we need to, when we are talking about we need to look into what is the bathymetry look like. And also when we talk about the earthquake fault zones, we need to look into how the various earthquake related or the tsunamis or the vessel movements actually affect the sediment stability or the flow of the sediments. This has very much applications in planning of the undersea cable route. So we recently have the undersea cable from the Indian mainland to the Andaman and Nicobar Islands as well. So how that risk assessment of these undersea cable routes would be done, sediment classification might come into the picture. Also understanding the polymetallic nodules, where in the central Indian Ocean basin we have the polymetallic nodules. So if the sediment classification can help us in mapping the spread of these polymetallic nodules, that can be that can be crucial as well. Another major application is understanding the sediment bearing capacity. Now sediment bearing capacity is actually the maximum load that can be taken by the sediments before any excessive settlement or failure happens. Now this is actually calculated based on what is called the bearing capacity factors, and these bearing capacity factors are based on what is the type of sediment, whether the sediments are do they have more friction, or what is the type of sediment, it's a silt, sand or clay itself. So the bearing capacity is affected by the type of sediment itself. So if you are able to link the results of the sediment classification to the sediment bearing capacity, these have various applications. Also, if we look into what is the sediment transport near the pile foundations of the various bridges itself. So we have the bridge piers. If they are subjected to a lot of local scour, that is a lot of erosion happens, so that it affects the foundational stability. In such cases there might be a differential settlement of the bridge itself. So there have been cases in Bihar itself where due to this covering there is this differential settlement, endangering not only human lives but the infrastructure damage is a lot as well. Now this kind of sediment bearing capacity can be useful in the construction of offshore refineries, wind turbines, say the various ceilings can also be, the foundation design is also affected by this sediment bearing capacity. So if we are able to have an initial estimate or an initial dynamic mapping of the sediment bearing capacity, that gives us a good estimate of having proper planning. Apart from that, the major application also lies in the strategic resource deployment. So in case of deploying heavy equipment, we know the sediment bearing capacity, initial estimates of sediment bearing capacity, we can get an understanding of what is the maximum load of the equipment that can be taken by that particular soil itself. Also, say when we need to have trenches in a particular soil, understanding what is the type of sediment would be very crucial in defining what would be the depth of trenches or the dimensions of trenches itself. This also finds its applications in having this mobile bridging equipment and in amphibious operations as well. So, say in regions such as Sir Creek, if we need to deploy such bridging equipment, we really need to know what would be the maximum load that the soil can sustain without failure. Again, if we could using the remote sensing methods or the acoustic methods, if we could have a mapping, a large scale mapping of or a heat map of the sediment type, of the sediment bearing capacity, it helps in the proper tactical planning itself. Another application is in the benthic ecosystem monitoring. So the benthic ecosystem are the or is the flora fauna which resides in the lowest most part of the seabed. If we are able to relate how the sediment flow, what is the sediment type, and the sediment constituents actually affect the benthic ecosystem health. So if we are able to uh, uh, integrate the sediment classification data with the environmental parameters, the species distribution itself, we might be able to look into what is the benthic ecosystem health, leading to a proper environmental impact assessment, especially when we talk about the fisheries, the aquaculture, or the coral reefs as well. Another major application comes in the abiotic element detection, where we can use the sediment classification techniques like acoustic sediment techniques to look about the marine, what would be where is the marine litter, or we can map the ship debris so that the navigational is secured. We can also use this to uh, actually have understanding of the seabed, so that the in cases of say underwater mines, are we able to detect the underwater mines through the sediment classification? So this abiotic element detection can also be a very crucial application. So coming up with how our sediment management techniques of our sediment classification and transport can be actually useful is, say for example, we have a particular location where dredging needs to be carried out. If we have the satellite data, if we have the acoustic survey data along with the hydrodynamic data, and then we are able to process that data, what we can do is, if we are able to find using the acoustic data what is the different sediment types and what are the thickness of the layers of these different kinds of sediments. So if we are able to map the thickness and the type of sediment, we can be able to have a good estimate of the volume of the sediments. So we can do this exercise pre-dredging and post-dredging to identify what would be the amount of dredging, that amount of sediments that are getting dredged. Understanding what is the sediment types actually helps us in a proper in having proper dredging techniques, whether hydraulic dredging or mechanical dredging is required, or even when the dredging is done, these sediments can be reused again if the sediments are have proper mechanical properties. These
Romit,
can be
2 more minutes for you. Huh?
Yes sir, yes sir. So if the sediments can be used again. So again this has also has proper applications in the disaster risk management as well. So if we are able to have proper idea of the pre-flood level and the post-flood level, we can integrate this various sediment parameters, the flood levels as well within the disaster management plans itself. So what we are actually planning is that we have this multi-data source integration, so that we have proper integrated with the local knowledge as well, so that we have evidence-based planning. Now the major challenge that lies is that we have, even though if we have data from various sources, there is no single platform to actually connect these various data. There might be data reliability issues, formatting issues as well, and there might be issues of data sensitivity as well. So how are we going to go about it? Here our major contribution comes where we have UDA-driven approach, where we integrate all of this data together within a combined marine spatial planning framework. So we could have different data parameters stacked together, and then uh, we could have this data within a particular this marine spatial planning. We could have real-time data analysis running in the back end, so that we could make data proper decision-driven systems as well. Now these systems are not only scalable but can also be adapted to different conditions. So for freshwater, for coastal systems, for lakes, for estuaries, this marine spatial planning type framework can be adapted to different conditions as well. So what our approach is basically is, for a particular region of interest, we have proper field validation using taking actual sediment graph samples. Acoustic sampling is also done apart from the remote sensing based data. Now once we have all of this data and understanding what are the pressure, temperature, the salinity measurements within that particular medium, we can go on to having this proper pre-processing, post-processing of data, including noise filtering algorithms, or employing some mathematical models, so that we're able to extract data from the raw acoustic and the sediment data, and that can be fed into an analysis tool where in real time we would be able to see the correlation between different parameters or the heat maps, and then that can be used to make again proper decision making under various and we can actually be able to map the flow of the sediment under different hydrodynamic conditions itself. Now these are some of the case studies that we have taken up. This was taken up in the Khadakwasla dam, so that we are able to validate the acoustic based sediment classification. So here we had the various acoustic systems like the sub-bottom profiler side scan sonar deployed on the ships. Apart from that, we also took the CTD measurement, that is the salinity, temperature, pressure measurement, so that we are able to map what is the speed of sound within that particular propagation medium. Using this data along with the raw acoustic data, we applied some noise filtering techniques, fast Fourier transforms as well, and then we employed a model called the reflection coefficient based model. We are taking use of the reflected and the transmitted energy of the sound of the acoustic waves. We were able to map the reflection coefficients. Now these are unique for certain kinds of sediments, and so we were able to deduce that most of the seabed sediments are of the type of silt and sand, clay and silt. Now this was validated by our laboratory experiments as well, that most of the sediments are of silty clay type. A similar thing we are doing for Ujjaini Reservoir itself, but apart from acoustic survey, we are also looking into the remote sensing and a larger environmental impact assessment as well. So currently we are going through the remote sensing or capturing the satellite imagery for the Ujjaini Reservoir, and we have also created a plan for the acoustic sediment classification for the Ujjaini Reservoir itself. Another work that we have done is the urban flood mapping, where we have taken use of the digital elevation models, the rainfall and the rainfall data to see under different conditions how the sediment flow might happen, or how what would be the extent of the flooding under the extreme conditions. So this also helps us in having some large scale disaster management plans ready. So finally, to give you the whole larger picture, see, in the Brahmaputra region, we have a lot of sediment influx, and it leads to a lot of challenges. Say, bank erosion is there, the path changes, the river path changes. So, how our acoustic and the remote sensing solutions can actually help us is to have proper continuous monitoring over a large spatio-temporal range across various discharge conditions, flood conditions, and flow path changes, and then we are able to link them to the sediment classification, to sediment transport, and then creating a proper AI-based prediction tool, so that under different conditions we might get, okay, so these are the sediment parameters, or this is the flood level, or the sediment concentration under different conditions. And so finally, this needs to be looked into in case of, say, the port development, the freshwater systems, the benthic ecosystems. So all of these are linked to sediment management. So there is a very larger picture that we are trying to solve currently. So I think, yeah, that's it from my side.
For your insightful and a very forward-looking presentation. So given that, one of our speakers is is running out of time, so I quickly jump into inviting Dr. Amit Rajan, who is a research fellow at the Institute of South Asian Studies, National University of Singapore, to come in and share his comments with all of us.
Yeah, thanks. My friends are waiting there for me. About this presentation, if you look from my angle as an academic, I missed an argument. What is the basic argument you are trying to make with this presentation? Second, you have taken a broad picture. Means you are talking about the sea, you are talking about Ujjaini River, you are talking about Brahmaputra, you are talking about dams. So you are talking about everything. So why don't you focus on only one, like either sea or a river? Even if you are looking at river, just go for one river or one dam. Otherwise, you are saying everything without having any concrete conclusion. Third, I don't know whether it's a research paper, academic research paper, or policy thing, because you have used many times while you're making presentation that we need. So that means that you are trying to give plan to someone, like a policy paper. Coming to the content, if you look at the dams, especially on to transboundary river dams within India, or between the India-Pakistan, or India-Bangladesh, or even India-China, if you take, sedimentation is a big problem. If you look at India-Pakistan, after this IWT was suspended, India flushed out the sediment from its dam. If you see the IWT 5 years back, they were when the people from two countries, water diplomats meeting, they were not able to have a consent to flush out those sediments. India has its own argument, Pakistan has its own argument. Same case is with India and Bangladesh, you can say. And we don't know how much sediments come from upper riparian to Brahmaputra River or Subansiri River or Lohit River. So we don't have much idea because we don't have exact reliable data for that. So these dams, sometimes what happens that if the sediments come, that can create a problem between the two, especially between the two transboundary interstates. But then there's also issue between Karnataka and Tamil Nadu, the dams. There's also issue between the two states from where they share a single river. So they also may have a issue of sediments. So how is there any solution to resolve those political issues or that economic issue? And sediments also affect the local economy, that you have a local population, especially those who are depend on those rivers. Then second content, when you talk about dredging, dredging has created some issues between India and Bangladesh in past, because the two countries have to make their consent that okay, so we are ready to dredge, but due to some regions, maybe political regions or economic reasons, the other country says no, we don't want, and that is affecting the economic environment. So that may also create some conflict or may leads to political tensions between the two countries. So what solution, what either from political point of view or economic point of view, what solution is there to control this over sedimentization of rivers that can create a conflict? Because, and sediments also, suppose if sediments are not dredged properly and the two countries sharing a canal or two states sharing a single canal, that can also flood the region, and that may create a problem between the two regions. It has happened in Kashmir. The dredging has not been done, and due to over rainfall, extra rainfall, and there was a flood, and entire city was flooded. Uh, so how we are going to deal with, or how one can deal with this situation? And if there is a conflict, what is the solution? Is there any solution to uh, to uh, you know to manage that those conflict over sedimentation, over sediments? Farakka is a case. India and Bangladesh are now in process of discussion to renew Ganga's water treaty. But sedimentation has been a big issue for both India and Bangladesh. Uh, Flooding, two sides. So that has been an issue. So how the two countries, especially the two countries, because you can manage the conflict within your country, or Pakistan can manage, or Bangladesh can manage, but how whether this conflict can be managed between the two countries, and if they can, how what is the role of sediments, how they deal with those sediments, because they are natural. It's not that someone coming and putting sediments in the one river so that other sides can get some adverse effect. So how the two countries are going to manage those things? Is the dam a solution? The dam is solution to manage those sediments, or there is any other solution? Okay. So I have only these short comments, and it was a very insightful presentation that I like it, and it was like, as I said, that only thing which I missed is basic argument, and it's so broad, you're touching everything. So that's a bit from my side, it's not very much non-academic, maybe better for policy thing, maybe better for other paper, but not for an academic. And it was very descriptive, very descriptive. So I suggest you to, if you want to make it more verification, just look at sediment, look at whether river, take one river, focus how sedimentation is affecting or if you want to do on a seaside, just focus one region. So take either say Colaba port or some port in Mumbai or a port in Orissa or anywhere. So just focus on one. That will help you to you make the things more detailed and more it will provide a nuance to the study and add more value to the study, instead of having saying everything and then after that you find that there's nothing concrete coming out from the study. So that, yeah, thanks. I'm sorry if you feel bad about it, but this
No,
is my,
yeah,
yeah.
thank you so much. I just wanted to put one clarification that he's a technical research fellow, so he's more focusing on the technology part of it and the data-driven aspect. You rightly brought out it is wide because he's looking at the larger sediment management aspect in technology-driven, basically using the data analysis. But we have specific, like on Brahmaputra, I mentioned. We have a fellow who's looking at focusing on Brahmaputra, and his inputs go to her in terms of sediment management. But if you look at Brahmaputra as such, I mean, what you are talking about, a geographical or a particular system focus, there that research fellow looks at various other aspects also. I mean, they get input from, say, a person who's working on fisheries and aquaculture, or a person who's working on connectivity. So that research fellow focuses on an area or a particular system. But Romit is looking at sediment management from a technical perspective, how the data-driven or the challenges of the sonar that is used, or the challenges of sediment classification. And many times, as you rightly said, there is no data. I mean, most of the rivers, the policymakers don't have the data of those systems. So for them to take decisions, or even for negotiation, now suppose there is a bilateral negotiation between India and Bangladesh, without the detailed sediment transport study or the detailed data, it is probably not very meaningful to even negotiate.
They don't have data. The problem is that they don't have data.
That's what.
Yeah.
So yes,
no,
so that's what we're trying to highlight, sir.
My intention was not that. My intention was that nowadays what is happening, that those anyone studying environmental issue or climate change issue, most of the papers they are you cannot do without interdisciplinary. So you have science, you have environment, you have geography, absolutely, and then you also have social science. Yes. So in that case, when you mix it up and then you come up, because there's no one solution. There's no one solution. And just take an example, as you said, Brahmaputra dams is there. If Chinese are making dams, then India come out saying that, okay, so we are also going to make dam. But what happened, that the local population is against the dam, because they are facing that, they think that we are going to face the challenge. So we have to look at the technical aspect also, then political aspect between the two countries, and then also you cannot ignore the grievances of the local population who have the issue with that dam. So it's all interdisciplinary now. So I'm just saying what
no, sir. No, your inputs are very important.
I'm a social scientist.
I just wanted to, because that's precisely what you said, a multidisciplinary, multifunctional, multi-stakeholder approach. That's what the UDA framework tries to do. I mean, you rightly brought out there is significant fragmentation. Multiple stakeholders are doing on the. I mean, like even in a say river system, the fisheries department works in silos, independent of the sediment. I mean, the water resource department or the flood management department, and they don't come together. I mean, they are not even able ready to share data. So that's where the problem happens, because everything is interconnected. So point well taken, sir. We're definitely and when we meet for the Brahmaputra discussion, I think you will have a better sense of that coordination that we are looking at, sir. Thank you so much. Thanks. Really appreciate it, sir.
And good presentation. Thanks.
Thank you. Next up, back to you.
Yeah.
Yes, sir. Thank you, thank you so much, Dr. Amit Ranjan, for your kind comments and for sharing your thoughts about like the presentation and how this can be done. I think before we move on to the comments by the other speakers that we have today, we'd like to launch a platform that our engineering team has been working on, which is called the UDA Knowledge Center. So the UDA Knowledge Center is a repository of all the research notes or the research work that have been spearheaded by the research team at the Maritime Research Center. I'd like to share my screen to showcase the same. Yeah. So I hope the screen is visible. So this is how the front end of the UDA Knowledge Center looks like. And our research notes have been divided into some categories, such as blue economy, the research papers that come under blue economy, the research papers that come under maritime environment, the ones that come under the national security and science and technology. So, we consider it as a cutting edge platform on the underwater domain awareness. And so we have a section on the latest publications. Like recently, there's a publication that came out. It was last year in 2025, which was on the APY analysis for shrimp farming. Then there was another paper that came out in 2025, which was on the seaweed farming in India, from the barriers to strategic pathways for sustainable future. So similarly, we do have, if I talk in terms of the numbers, then we have around 73 plus research papers which have been uploaded to this platform, and the contributions have been made by 42 plus research authors for these 73 plus research notes and white paper and the gap analysis paper, etc. So you can just visit the Knowledge Center page of the Maritime Research Center's website, and easily access the plethora of research notes which are available on our platform. But before you try doing that, and you see the key highlights and the key observations and key recommendations that that have been put across before you open the main PDF of the research note, you might have to register yourself by filling in your email ID and the password that you create before you're able to access the Knowledge Center research papers. So yeah, that was about the Knowledge Center, and I'd like to thank and congratulate both the engineering and the research team for clubbing together on this and for making it happen. So good job by both the teams on that front. I think we'll now move on to the comments by the panel members, section of this webinar, and where we bring in a diverse views on the regional and strategic perspectives on the sediment management. So first of all, I'd like to call upon Rear Admiral Y.N. Jayaratnana, retired. Sir is a retired Sri Lankan admiral and hydrographer. He served as the chief of staff of the Sri Lankan Navy and a joint chief hydrographer to the government of Sri Lanka. He is a former commandant of the Naval and Maritime Academy and a commanding officer for the 4th Fast Attack Flotilla. So I hand it over to Sir for his kind comments.
So thank you, Dr. Arnab Das, for taking me on board. I am delighted to be here, and to start with, I would like to congratulate Romit. Young research fellows like you make our day very brighten, and getting these young research fellows to come forward and present, and that is where you, Commander Das, you come into play, and I'm glad that I'm impressed with what you have done so far in highlighting the underwater domain awareness. I know it is your brainchild and you are toiling it for long, and Romit, and it's a job well done. And yes, I agree with Dr. Amit Ranjan, that's too vast, but it is a good foundation. It's a baseline study to get the attention of the policymakers and the officials, how interconnected and how complex the whole matter is. So your paper covers all the spectrum. So naturally, it will require further subdivisions, and I'm sure MRC we can undertake these things. So divide according to the priority of effect. For example, this is the way I look at it. I would say the inland waterways, because the India is going to invest on the inland waterways. So that means the river flow and the silting and sedimentation are going to be a matter of concern. And then comes the reservoirs of the water catchment capacity, because the runoff are high. and we could see it's more than rain. It is the erratic weather conditions bringing more rains, and along with that, the increased runoff that is making our rivers and reservoirs filled with more sediments and more siltation. So coming to the estuaries, that is where the near coastal effect, then the marine spatial planning and the blue economy. And I would say these two prompted all of us to look at things, because you see, this sedimentation was, it used to be a scientific subject some 10-15 years back, but it is not, because these fix into our strategic posture and the strategic picture. So we need to take this into account. And Romit, so your paper covers very well the connecting all the dots, and why we need to make a focus effect on these things. So marine spatial planning and blue economy, I won't be much worried about in water depths more than 200 meters, because this will have a more effect on our livelihood and our marine science, spatial planning and the blue economy in less than water depth of 200 meters. So that's where I think we need to have prioritized our effort. And I'm sure MRC can find out many avenues of research in this thing, and young researchers like Romit need to work out on these things. So that will be the future, and that will be good for India, and that will be good for the region also. Some of our experience coming from this cross-border dredging during the Setu Samudram Canal operation in 2005, and in July it was inaugurated. So till about 2009, the dredging was taking place in the northern bank of the Pork Strait. So in the Pork Strait, and there are two banks, the middle bank and the northern bank. So northern bank was dredged, and when that happens, because of this water circulation, depending on the monsoons, it was having a transboundary effect. Now, I don't think a single framework can be fixed into the complete region or sub-region, because there will be some local conditions that affect into that. Now, that is where the data matters. Most of the time, as you rightly pointed out, there's no data. So if you have data, the modern day technology and the instruments are capable of playing around with these things. I would share some of my practical experience. In 2006, we invested on a UK Cerberus underwater detection systems for Trincomalee Harbour because of the separatist terrorist, the underwater threat. So when these were proven equipments, and when they were fitted in Trincomalee Harbour, we were not getting the results it's supposed to be. So the UK scientists and our hydrographers and our technicians were running around finding what's wrong with these things, why it is not working. Then ultimately we came to know that in the outer harbour of the Trincomalee Harbour, the freshwater flow from Mahaveli River have an effect on these detections. So these are how we started to realize how on ground, on field, how these things matters to us. So with these things, we enhance our understanding about the underwater domain, how dynamic and how serious that stuff is. And for a country like Sri Lanka, I would say, being an island, this accumulation and effect of silting and this have a drastic effect. For example, I'm sure you may be aware of a fishery harbor on the eastern coast called Oluville, that is south of Trincomalee, where with the Netherlands funds we built the harbor, but it started silting, so it is not usable. And at the same time, today the siltation and the silting are toxic because of the so much of chemicals and things that have been used on land, on the agriculture, on farming. And as a result of that, the toxic effect, and these things are visible in our coastline, the coral reefs and in the shallows. where the sunlight penetration is good, that create a lot of growth underwater. So these things happen on the reservoirs also. Now with the idea of having solar panels on reservoirs to gain more green energy, there will be side effect of that, because it stop penetrating of the sunlight to the water. So these things all need some studies and scientific approach, not just taking quick decisions. uh, Two questions I have for Romit. One of the slide at the beginning, you showed that how the sediment spread is taking place in the Bay of Bengal in the eastern coast of India. It was coming down. I wonder whether it was on the northeast monsoon, or is it on in a very generic distribution. Romit?
So I think it's more of a generic case I took. Did not go more into how the north, the west, or the southeast monsoon actually affects the sediment transport. It was more of a generic viewpoint.
Okay, right. That just to stimulate your thinking. You see, the further you come down from Chennai downward, especially on the Pork Strait and Pork Bay, there's no rivers that are feeding into the water, the ocean system, the oceanic system. So that is why you find the clay mostly on the seabed, and as a result of that, it became a very ideal ground for these benthic creatures, the prawns. It is because there's on the Sri Lankan side there are no year-round freshwater feeding or the sand feeding to the Pork Bay or Pork Strait, and same thing happened on the Tamil Nadu coastline, whether it is from Tondi or from Point Calimere, that side. There's nothing like that. So these things matters, and we need data. And whose responsibility is to collect this data? There are government mechanisms. Do they aware of these things? I don't think so. So that is where the Romit, your paper comes into play. So keep it going, and these things matters to us, and they are not just for India, it is for all of us. And I'm sure the ports, all the ports, somewhere along this port vicinity will be a major river. Now, for example, Colombo. Now, one of the dredging, the maintenance dredging need is the flow from the Kalani River, major river that feed into the with sands. See, in this island have a lot of sand accumulation, because all the sand out at sea originate from the land, and this sand accumulation is a economical benefit for us. With this sand, we create many things, and this sand is having an economical value and a financial value. So today, at one point of time, we may have seen this sand as a burden, but today it is not. So, with this comment, I would like to end my comments. So it's very well done, and it actually your paper prompted me to write a complete article for the paper. So when I write the article, I will share with you, Dr. Das. It will be on how we can benefit from these things. So I'm glad that you stimulated my thinking to write onto the paper. Thank you.
Thank you so much, sir. We'll really, I mean, normally Nishta is always on the lookout to request our panelists to contribute to. We also run a UDA digest, so and we will definitely further this interaction. And as you rightly said, sir, it's a multidisciplinary approach, and even Dr. Rajan also mentioned. Somehow, I think I could not clarify in the beginning. We have 7 to 8 research fellows working on different areas, and this keeps on increasing. We've had more than 300 interns who have been working with us in the last few years, and they contribute to those specific problems that you mentioned, sir, whether it is area specific, whether it is application specific, or it is stakeholder specific. And then we try to build the larger picture under the larger UDA framework. I mean, why should the data be collected only for, say, a defense application, or why should the data or whatever data has been collected, I consider it should be a national asset, or at some point, if we can kind of take care of our sensitivity of the classified data, it can be a regional data which is being collected, and I think there are mechanisms possible where our apprehensions of data classification can be addressed, and then that can be used, because most of the countries in this part of the world, particularly the small island developing nations, will be resource crunched, and they may not be able to invest significantly in modern technology or particularly the equipment. And that's why the modeling and simulation becomes a very important aspect. So I really appreciate your comments, sir. Thank you so much.
One more thing, Dr. Das and Nishta, just let me acknowledge the presence of Vice Admiral Adi Rora. I'm sorry I cannot identify others because I have not met, but these having the presence of another fellow hydrographer, I must acknowledge. So good to see you, Adil, and so I'm thank you for that.
What a pleasure, absolute pleasure, Admiral Jairatne. Very nice to connect you on this. I think I should compliment Arnav for having reconnected us after so many years.
Thank you, sir.
Always a pleasure listening to you.
Dear Admiral Jairatne, for sharing with us your comments and for giving us a glimpse into your experience of being Chief Hydrographer of the Government of Sri Lanka. So with this, I'd like to move on to the next speaker, the next distinguished panelist that we have. We have with us Dr. R. Chandrasekhar, who is a strategic analyst, and I'd like to call him to share his comments about today's webinar and what Romit presented in his presentation today. So.
Thank you, Nishta. Thank you, Dr. Arnav Das and the MRC for this opportunity to be present today amongst you all and listen to this absolutely fascinating presentation by Romit Kavre. Romit, congratulations. I liked your presentation. It was rich in data. It is an eye-opener for me, and it rang many bells in my mind. Just to encourage you, I must say that research is like evolution. It's a continuous process. But what I find, and I must mention this more for Dr. Das, is that many people take up a subject, delve into it for a while, and then leave it. Now, there is a critical mass of expertise which has to build up if the researcher is to serve the purpose of policy making. That has to come. Now, Rohit, you've caught on to this subject. I would urge you and I would hope that you won't leave it and carry on with this, because you're already standing on a high ground. You can only grow taller from here. The second thing is I want to touch a personal chord. Many years ago in 1992, I had opportunity to be on board the INS Investigator. That was when I was staff officer to the Army Chief, and we were on a visit to Andaman Nicobar. And something which, we were briefed by, at that time, the Vice Chief of Naval Staff, Surinder Prakash Govil. SP Govil, Vice Admiral SP Govil was the Vice Chief, who was with us. And in that briefing, of course, he covered the Great Bengal fan, the Andaman fan. But the Admiral just referred to, he said that if sediment carried by rivers and deposited along their banks as alluvium is gold, why is the same sediment, once it reaches the sea, become tinsel? So he at that time foresaw that there is value in what we are calling tinsel. Sediment has value. How we harness that for our good may not be now, but in a 10-year perspective or a later perspective, is something which we should reckon and factor in. Now, I'm not a technical man, I'm a bureaucrat, so I will take a bureaucratic approach to this whole presentation. And there are two words, phrases in the title itself which catch my eye. One is framework-based, and the second is Indo-Pacific. Now, when it comes to the framework, now, the Article 84 of the UNCLOS, we have now made an application to the CLCF for extending our continental shelf. Once that happens and the approvals come, then we would have seabed area which almost equals our land area. But as a government, as a nation, are we placing, there is enough riches under the seabed as there is perhaps on land, maybe even more. So what are the mechanisms we have? for harnessing the wealth which is there in those seabeds, is the point which I want to raise. And here comes an aspect which Dr. Das has raised in his opening remarks. That is about the fragmentation among stakeholders. This is the real problem. Take sedimentation itself. Under the allocation of business rules, the subject of deep ocean survey and exploration, this is allotted to the Ministry of Earth Sciences. Whereas river sedimentation comes under the ambit of the Ministry of Water Resources. No harm in that. But is there a collaborative arrangement between the two? Is there an exchange of the science and data between the two? Are they working in silos? Is something which will have to be kind of overcome. Then we have a beautiful, a mission of the Prime Minister called Sagar Manthan. No mention of a seabed in that. In fact, I thought both the poison and the Amrit came out of the seabed. But there is no cement in the Sagar Manthan. So I think the scope of the Sagar Manthan should be enlarged to cover even sedimentation and a deeper analysis of the seabed. Now, one of my naval friends whom I went to, because the subject was such, I thought I should refer it to a few of my friends. And he mentioned that, he mentioned the NCPOR, the NCPOL, the INCOIS, the CMLRE. These are the various organizations which are dealing, but the mandates of none of these organizations really makes a mention of seabed and sediment management. So here again, we need to kind of see that there is an institutional kind of ownership of the seabed somewhere with someone. Maybe a new agency, it would really merit that. The other point which I want to make, and which Dr. Das and Ronald both mentioned, is the quality of research, what is available. This is a data-driven field. Data is gold here more than anything else, anywhere else perhaps. Now, when it comes to our own EEZs, there is data being collected. There are provisions for private players to collect data. But this data has to be captive and available to, it can't be commercially exploited without the country knowing what the data is. So the institutional arrangements for collation of that data, for enforcing their submission, is something which have to be brought in. You have the Offshore Areas Mineral Development Act, which was enacted in 2010, but then the rules under that act were notified only in 2024. So, if that is the kind of urgency we have about ocean development as such, mineral wealth, then we have a lot to kind of do it further. Now, point I want to make is about, on the global side, you have the ISA. The ISA now is also kind of, apportioning fields for research and commercial activity. But it is doing that for a global common. Now, when you do that for a global common, the data which is available to the ISA, which should be fed in by everybody, should be available equally to all its members. Now, India as a member, as a leader of the global south, must raise this and have a strong presence and a voice in the ISA to ensure the data availability to everyone, so that if there is a commercial exploitation in your near neighborhood outside your EEZ, you are a stakeholder, you have right of first refusal, something like that, where the proximity advantage should be available to a nation state. Now, Rohit made a very interesting point on the multi-data source integration. That caught my eye, because it brings you immediately to a point is who is going to collate? Is there an authority we have? I don't see that authority yet. It should correctly be the Indian Navy, and it should be the Navy who should be the first obtainer of any data which is being collected. So, of course, we have the Mahasagar project, where again, we should have this as yeah, that's the points which I wanted to make. I won't take too much of time. Once again, thank you, Dr. Das. This is a pleasure, really. It's something which we should work on. And if there's any collaboration which you would require of me, I'm always there, which you know.
Thank you so much,
Thank
sir. Really, always I've been
Once again,
wherever
congratulations.
we have sat together in a closed door or otherwise, your comments have always made an impact on me, and definitely I appreciate. And as you rightly brought out, sir, we need infrastructure in terms of a policy infrastructure where all the data can be. I think the Gati Shakti is definitely a framework that the government has announced. And in fact, Dr. Ajay Kumar, the former Defense Secretary and now Chairman UPSC, even after he had attended one of our workshops, he had traveled to Pune and he wrote this article in Business Standard that there should be a PM Underwater Gati Shakti initiative. So I think there is a Business Standard article that he has put together. And as Romit has tried to, and that's what my instructions to him was to broaden the thing so that we at least understand the entire sediment dynamics or sediment management dynamics, so that how all of it can put together. And sir, we have taken your directions very seriously. Romit is pursuing his PhD from IIT Delhi. He's a BTech civil engineering from IIT Delhi in any case, and he's now pursuing his PhD also, and he's continuing on the same topic. So definitely we take, and this is, I think, almost 6 to 7 years of work, which one of our research fellow is doing her PhD in Austin, Texas. I've had two PhD students who have already finished a few years back. So we are definitely pushing this, sir. I think one webinar is not enough to talk about all the work, and but I do take what Dr. Amit mentioned. So we have separately fellows who are looking at specific aspects. So even we have fellows from Philippines who are working on how UDA can be looked at in terms of a bilateral or even as at an ASEAN level also. So we are looking at multiple dimensions, sir. So I really appreciate your comments, sir. Thank you very much for joining us, sir. Nishta, back to you.
Thank you so much, Dr. Arch and Chandrasekhar, for sharing your comments with us. I think we'll move on to the next speaker now. We have with us Vice Admiral Adhir Arora, retired. It is my honor to introduce Vice Admiral Adhir Arora, who is a former chief hydrographer to the Government of India. A specialist hydrographer with decades of experience, he has led extensive hydrographic surveys across the Indian Ocean region and played a key role in maritime boundary negotiations at the international level. His operational leadership during the 2004 tsunami response and contributions to hydrographic cooperation with partner nations reflect a distinguished career dedicated to maritime excellence. So over to you, Vice Admiral Adhir Arora.
Thank you so much, Nishta. Firstly, absolute honor to be a part of this August gathering. I really feel honored because it's got all the luminaries here. I think right from Ambassador Mudgal, who has been in Mauritius, and I had the opportunity to visit Mauritius 4 times during my career by ship for undertaking continental shelf surveys, as well as for doing the Indo-Mauritius Hydrographic Cooperation, leading the delegation there. And Admiral Jayaratnaya already acknowledged his presence here. We also have collaborated in the hydrography part of it and ensured that Sri Lanka and India have moved hand in hand whenever there have been any hydrographic challenges. We have really covered a long distance. Very absorbing listening to everybody. And firstly, let me compliment Romit. Absolute absorbing presentation. I think he covered a very, very large canvas. He had to cover a large canvas because sediment is not one thing that is isolated to only one part. It is spread all across the oceans. 70% of the earth is oceans, and sediment is a part of that in every corner. So fantastic. Before I move on to some comments from mine, I would just address a few things, queries that Dr. Chandrasekhar had put up. So firstly, sir, there are a few things about the hydrography part. The hydrography, as per the Government of India business rules, is required to undertake, the chief hydrographer rather, under the Ministry of Defense is required to undertake all the navigation surveys and preparing the navigation charts, not only for the use by the Indian Navy, but also by the use of Indian Merchant Marine and all merchant marine across the world. This business rule actually flows from the IMO Charter of the UNCLOS, where UNCLOS says that every country has to ensure that safe navigation is provided to every mariner in their coastal areas, in their approaches, and wherever they are in close contiguous area to the land. So that responsibility has been done by the chief hydrographer from eons. So the legacy from the colonial past, it has been passed on. That is how we have a Sri Lankan chief hydrographer, we have one from Myanmar, we have from Bangladesh, because the responsibility of collecting the data is extremely tedious. You have embarked INS investigator. I'm sure you would have had an insight of the routine where nobody sleeps 24/7, 365 days, whether you're in harbor or when you're sailing, you're on. The propellers are churning. That is how the minds are churning. And because of this churn, that data finds its way onto the navigation charts. If the churn was not there for the eons, this data wouldn't have been there. You see the colonial charts, you see our Indian charts, even before the colonial powers to be came here, all have got fantastic data. That is why we were the primary seafarers going from India all the way to Indonesia. We were the primary seafarers going from here to the Persian Gulf. We were the primary seafarers who were exporting before the colonial powers came out here. The strength of navigation was there with us, and it was the hydrographers who were also the early explorers and the diplomats who ensured that the area was safe for navigation. Nobody wants to go out into the sea if you do not know if there is a rock or a reef. Nobody wants to be stranded. Nobody wants to become a wreck. So that is where the importance of hydrography came in. We are just carrying on that legacy on our broad shoulders and ensuring all the data for the country is being collated in one place. What is required for the mariners, that is open source, is provided to them. Last year, this organization under the Ministry of Defense earned a revenue of 100 crores only by selling the electronic navigation charts, which is again mandated by the International Maritime Organization. So we follow international standards. We have very exacting requirements, and the business of rules are scrupulously followed to ensure that everything is hunky-dory. Gratifying for us is that not a single incident has taken place in the Indian waters because of an error in our chart. It is navigation errors by the seamen, not by the errors of a chart. I think that itself is very gratifying. So that puts into perspective who has the maximum data today and who's collated it. This data lies in the repository in the National Hydrographic Office at Dehradun, and it is utilized for multifarious purposes. The one that is required for the mariners is given to them. Other data which is classified is to be utilized for the requirements that come from time to time. So if this is the background of the data you're talking about. Now, you're talking about sediments. When we are collecting the data, it is not only the depth. We are picking up the bottom sample from the ground as much as 100 meters, 200 meters, 300 meters. And that data, whether it is silt, clay, fine sand, coarse sand, is depicted on the chart. If a ship has to anchor, he cannot anchor till the time he does not know what the bottom is. Imagine a ship anchoring on a rock, the anchor will break. So everything underneath where the ship is should be known to him. That is where the sediments part come in. So all the charts are quite replete with how the sediments and where the sediments are. Maybe not very concentrated, but maybe the requirement is for the mariners because this is the minimum they can do. For the fisherman wants to know that nets should not get entangled into a rock. It's there on the chart for him to see. And these charts are available free. The charts are available, though at a cost, but they're available. It's an open domain. That is where I said you want not only monetize them, you democratize them equally in equal measure. Now, coming to the points that Romit had raised, I think we are blessed to have such a wonderful subcontinent where we have the maximum number of sediments. It's not an impediment, it's a complement that we have them. We only need, like you said, sir, we need to harness these sediments to ensure we get the best from the soil that is available with us. Now, how do we harness this potential? Now, that's a very, very big question. Like Kamada Das just mentioned, situational awareness. We just do not have situational awareness because everybody is collecting the data in their own vertical. When anybody is collecting the data in their own vertical, it is with them. You just mentioned the Jal Shakti Ministry. He is responsible for all the inland water data. And I think they're doing a very, very good job in doing that. So they do their bit, they do the reservoirs, they do the dam, and I think they're doing a fantastic job. It's only how the data is to be utilized and how the data is to be used by another agency. That is where the bottleneck is. Now, do I need the complete data to be populated and put on the, let's say, a platform? Let's say marine spatial planning that we are all propagating about. No, we need to put the data that is required for a mariner to have a glance. The other layers of data, unclassified data, can easily go into this marine spatial planning. Absolutely, there's no problem at all. Let's say I want to know where the windmills are, wind farms are, where it's available, should be available to me, because if a pilot is flying from there, he should know the height of the wind farm. If a height of a wind farm is, let's say, 80 meters, I'm sure the pilot will not go there. A helicopter will not go there. In a Survey of India chart, you may not have that. But on a navigation chart, on a sea chart, you'll have that because you have marked the wilmot there. So that is available on the, should be available on the your marine spatial planning domain. And that's what Commander Arnab Das has always been mentioning, that have a marine spatial planning which is generically available for all the mariners and the users. You want to have let's say a cable which is going from Mumbai and going all the way to Gulf. A fisherman needs to know where it is. Otherwise, he'll put his anchor there and he'll cut the cable. There have been instances of Bombay. I think every 1 year or 2 years, the cable gets cut. So these are the things that need to go into a marine spatial planning. And when you're saying a marine spatial planning, sediments are the best thing because a cable will go through where there are sediments because sediments are soft. It will never pass a cable through a rock because you cannot cut through a rock and try to put a cable there. A cable will get cut there. So sediments are very important. So we need to know how to harness it. Coming to the port development, I think the ports have a fantastic potential. Dredging. Why can't the dredging volumes be taken up by the ports every year? The ports do the dredging every year, or maybe they do every 6 months or periodically. Now, if I got the data of the last 10 years, do I need to work out again? AI can help me out. This is what I'm sure that the MRC is trying to portray, that why can't AI be utilized for the port dredging? And imagine I giving this data to the Dredging Corporation of India. Dredging Corporation of India for the next 10 years will say, okay, fine, my requirement from Bombay Harbour is, let's say, X cubic meters. So I need to have these many dredges for this much time for allotment for the next 10 years. Then the next dredging part of Dredging Corporation, he says that now I've collected this much of volumes of land. Where do I throw it? Do I throw it for any reclamation? Does anybody want to use it? Or do I dump it back into the sea without any use? So this is where the planning of a port can come in, and we can harness this complete mechanism through AI. So this is one part that I thought I would like to share, where the economics part can be dovetailed very easily into the marine spatial planning or the port infrastructure. Ground truthing, I think it's equally important because if I do not have a ground truthing, and if a ship gets grounded, then what happens? He can claim for insurance from the port for wrong information. Who is responsible if a ship gets grounded? A port is saying, I've got 10 meters, but the ship says, okay, fine, you have told me 10 meters. I'm coming inside. I've got 9.5 meters and I get grounded. So what does the port say? I'm sorry. He can't say that. So that is where it is very important to have periodical surveys done again and again and again. Do you know, as per the statistics, just 30 centimeters of depth, now this is called hydroeconomics, 30 centimeters of depth can give me 2,000 tons more. 2,000 tons more. And that 2,000 tons, let's say, if I'm getting 2,000 tons in the present crisis, let's say 2,000 tons of petrol, 100 rupees per liter, that's 20 crores. 20 crore rupees, 30 centimeters. And that's what hydroeconomics is. So I need to give, or we need to give, the exact depths to any of the ships coming in. And that 30 centimeter can make a difference. This is where, again, AI comes in very importantly, which can be taken care of, because again, you need to clear the sediments. Let's say offshore platforms. Offshore platforms, this is serious business, because offshore platforms, where they're going to be, is coming under the ambit of Director General of Hydrocarbons. So when Director General of Hydrocarbons is going to ensure that I need to put an oil rig on the west coast, he sends a vessel to first do a hydrographic survey. Then he sends a vessel or a survey company to do the seismic survey. And then after that, he physically puts in pods to get the coring sample and tries to find out where the hard bottom is. Because there is no oil rig in this world which will go and put itself there without the ground truthing and the complete scientific data. So this is one place you cannot even think of doing any AI. You have to do the ground truthing here. It is exactness. Imagine if there's a punch out. A punch out means one of the oil rigs, one legs, just punches the soil and goes inside. The whole oil rig will collapse. You cannot take a risk like this. So instances like this, sediments being there, you have to do ground truthing to get the exactness. Coming to man-made structures, I think jetties, piers, groins, we have made some amount of avoidable errors in these cases. Only if we had had data, the organizations which planned these groins or jetties, it could have been better. Let's say take an example of Kum River in Chennai. There is a sludge in that river and the mouth never opens. Right from the Chennai harbor, that stink can be, is all over. So why did this happen? They made two groins even without understanding what the longshore drift is. A longshore drift is nothing but the lateral drift. A lateral drift is nothing but the sediment transportation. Everybody knows that on the east coast, because the waves are hitting the coast at an angle, the drift of the sediments is from south to north, at least for 9 months. It's only for 3 months with the retreating monsoons, you have the reverse currents. These groins or the extensions from the coast could have been made in a better way. I'm just giving a few examples. Marina Beach is a consequence of having the jetty of Chennai coast. Marina Beach was not there earlier. 100 years back, Marina Beach was next to the road, East Coast Road. So these are the consequences of man-made avoidable errors which we could have seen. But with lot of data being collected now, and again, you cannot do extrapolation till the time you do not have big data. You got to have data. So collection of the data and having data is the most important thing. And that's what MRC has been trying to say, that I think if we have to populate data, but how? That's the question. I think that is where governance comes in. You got to break the silos. In every silos and every vertical, you can say, give us this much data, so at least we can understand what is happening at sea. Military applications. Well, Sediment is a friend and sediment is a foe. You have to befriend the sediment in your waters to ensure that you gain the maximum from this. India subcontinent also has the maximum turbidity. Because of the turbidity, you just don't know whether underwater submarines are hiding, So that is another big advantage for us. So this is how the military applications, I will not go much into the military applications and I'll skip that. Tourism, I think from the beaches, from Ganpati Phule to Goa to Kovalam, you name it, Mahabalipuram to Gopalpur, to Rishikonda to everywhere. You got the best beaches in India, one of the best beaches in the world. It's only that we have not been exploiting it. How has this happened? This has happened because of the sediment transportation. We got the sand, we got the silt, we got the clay. How have we got the rare earth? Those berms and dunes have again happened because of the longshore drift and the seasonal surges. We got fantastic rare earth dunes, sand dunes, which are good around 10 to 12 meters in Odisha coast. We got rare earth in that. How's that happened? So this is all courtesy the sediment movement from there. Why are we slowly opening up the Andaman? I think 5 islands are already being opened up on public partnership. Because of this, there has been sediments and there have been fantastic beaches. This is just coming up now in Andamans. 5 new islands are just coming up. So India is opening up. So we need to harness our sediments in such a way that they complement all that is around us. And just before I sign off, just to put the things in the right perspective, India's EZ that was calculated again by the hydrographers, though published by somebody else, is 2.11 million square kilometers. That's the latest one. That's 2025. The coastline now is 11098.81 kilometers and no longer 7615. And the number of islands that we have is 1379. That's been documented as late as last year. Thank you.
Thank you so much, sir. Couldn't have been a better kind of summing up in the sense of your experience. And I mean, you've been on the ground dealing with it and even at the policy level. And as you rightly clarified, Naval Hydrography Office is not just for the Navy, but it manages for the entire country. So thank you so much, sir.
Welcome.
Sharing valuable insights with us and for drawing from your vast experience to enrich the discussion that we had today on the sediment management. So now we'll move on to the closing remarks section of our webinar. And for that, we have with us Ambassador Anup Kumar Mudgal, sir. I'd like to call him the strategic advisor to MRC before anything else. So apart from that, he is a distinguished career diplomat of the 1984 batch, and he retired in May 2016 as the India's High Commissioner to Mauritius. During his over 3 decades of service, he has held key roles and responsibilities at India's Ministry of External Affairs. His domain expertise spans from topics such as maritime security, ocean economy, blue economy, trade policy, etc. And post-retirement, he remains deeply engaged in strategic initiatives and activities, serving as, he served as one of the key persons at FICCI's task force on blue economy and the steering committee on blue economy under the PMEAC. So over to you, Ambassador.
Thank you so much, Nishta. Thanks, Arnab. Another opportunity to interact with these young minds. Admiral Saab, in fact, I remember very much, when you used to come and we used to present those hydrographic maps to the Mauritian authorities and how they used to appreciate that. Because the beauty of these small island states is that they have a lot of water, but somehow they do not know what is there in that water. And I think your effort, in a way, was telling them what exactly they have under their own water. And that is the context of today's presentation. In fact, when you listen to Romit in isolation, sometimes you feel why so much detail on sediment management. But I thought, I have been with him throughout this journey of preparing this report. But that was not the only path. When we talk about MRC is simultaneously walking on a large number of pathways. And we are trying to converge those pathways into finding solutions so that the man-made activity is not always incompatible with the laws of the nature. So as Nishta mentioned, I have been working on blue economy for now almost 10 years, or a little over that. And we realized that with the land-based resources depleting, we would be rushing to the oceans for more resources. Not that we have not done it in the past. Historically, we have always worked with the oceans for food, transport, recreation. Then later on energy, now we're talking about renewable energy. We are talking about non-conventional new areas like biotechnology. We are talking about seabed mining and so on and so forth. Now, we thought if so many sectors simultaneously rush to the oceans, are we looking at an intersectoral conflict situation? And which would then be manifested in the ocean's behavior. And if you look at the contribution of ocean beyond its economic value, it has tremendous intangible benefits. And we can talk about the oxygen cycle, carbon cycle, weather stabilization. You can talk of any number of those things, biodiversity. And we have been saying in all meetings, if, for example, climate stabilization is, in fact, one of the most important pillars of security, in fact. We talk about all kinds of securities, but if the environmental stabilization is disturbed, if the climatic stabilization is disturbed, I think that would be one of the very major threats to our own security. We talk about food security, we talk about energy security, we talk about other kinds of security. But this is a horizontal threat to all aspects of security. Therefore, understanding the ocean's behavior, because when we are dealing with a partner, because ocean is a partner, and we are dealing with a partner, it is very important to understand the language of the partner. If we do not understand the language of the partner, then the partner becomes a foe. As Administrator, you mentioned, the sediments are both a friend or a foe, and it depends on us whether we want to convert that into a foe or a friend. And the same thing is in ocean. Whether we want the ocean to be our friend or a foe will depend on whether we understand the ocean's language, or for that matter, all water bodies. And that is where, in fact, I am maybe wrongly so, but I am a very strong believer that the ocean's behavior is determined mostly by what happens under the water. Underwater is the phenomena where there could be physical changes taking place, chemical changes taking place, biological changes taking place. And unless we understand that part, we would not be able to understand the ocean's behavior or its language, and we will not be able to forecast in what direction will the ocean behavior go. Right? So this is when we talk about MSP. MSP, basically what I'm trying to do, we are trying to live with the environment rather than fighting against the environment. And for doing so, we need to understand the environment. Now, unless I know how the environment works, I won't be able to fine-tune my own activity so that it is in compliance with the nature's behavior, nature's law. If you're already facing so much of problem, in fact, if we look at the environmental degradation that we have done, we have completely messed up our land resources. We have messed up our air resources. We have messed up our water resources.
And now we want to head to the oceans, thinking that, oh my God, they may have more resources than we have been able to destroy. But if we go there with the same behavior as we have done on land, I'm sure we are looking at a very major threat to the humanity. And no, I don't wonder, in fact, when experts in the field, including the United Nations Secretary General, has been calling climate change an existential threat. And I totally agree with him. I see no reason how to challenge that. I'm sure there are people who don't believe in this, but I have studied these things for many years now, and I totally agree that climate change, if there is one single most serious threat to humanity, it is climate change. And that is where, in fact, the whole effort MRC is putting together in trying to understand what are the consequences of our action in the environment. I'm sure that we all have to agree that we want good life, and good life needs resources, and they have to come from this limited resource that we have. Now, I always say, we came from a very small economy, which was just about few $1 billion value some 2 centuries ago or before the Industrial Revolution. And we have taken the size of the economy to almost $120 trillion. And this $120 trillion we created over a period of something like 250, 300 years. And in the next 20 years or 30 years, we want to add more $120 trillion. Now, if you want to add that value to our economic activity, can we imagine what kind of resources we need? The resources which we gathered in the last 250 years, we need similar resources in the next 23 years. Now, we can do it the way we have done in the past and face the consequences, or we can do it better so that the consequences are mitigated and we are able to live with the environment. Now, coming to Romit's presentation, Romit is a young researcher, basically. He is still growing in that. But the idea was to start with this sedimentation management in a broader sense of the term first. Do we understand the whole thing? Then we can go into micromanagement, how to deal with a particular river or a particular port or a particular situation. But the global behavior of the sediment had to be first understood by Romit, who would, I'm sure, play much focused role. Because unless we understand the process, we cannot convert that process into solutions. I can understand we are all seeking solutions, but solution would not come till we understand the process. So Romit's effort right now was basically to understand the process. How these sediments are created, how they are transported, how they get aggregated, how they get deposited, and then how they create problems. We from childhood we have been hearing, the rivers change their course. Why do they change their course? It's the sedimentation. Yes. And I have seen, I've lived many years in Europe, Americas, and I have seen how they manage their inland water systems and how regularly they manage the sediment. If they stop managing sediment, their inland water transport system will collapse. Not only the transport system will collapse, it will also have an impact on tourism. It will have impact on biodiversity. It will have impact on their fisheries. It will have impact on their drinking water system. So it's a multiple ways mismanagement can hurt us. Now, data is, as other speakers mentioned, even if you're talking to a cross-border partner, most of the disputes arise because the data is lacking. Because we are trying to make an argument through the gut feeling. Our gut is different from their gut. As a result, we are not able to come to a common decision. But if there is a credible data available to support the argument that we are making, it will become easier for your partners to understand the argument that you're making. So I think that is what MRC is trying to do. They're trying to collate data from different silos, as Admiral Arora mentioned, and then try to see, could there be a common silo where this multiple variations of data could be collated into a solution. I'm sure it's a very difficult job. It's not an easy job. If it was easy, we will all not be sitting here and talking about it. It's a very, very complicated thing. It's heavily data dependent and heavily analysis dependent. And unless, somebody does it, it won't happen automatically. So somebody has to do this very boring job. It's a very boring job. For example, when you sit across a table for discussing diplomatic outcomes, that's sometimes very exciting. But that exciting thing will not happen unless somebody does the boring job. The boring job is get the data, apply the integrity to the data, analysis of the data in a credible manner, then project your viewpoint to your partner. So talking of the international cross-border issues. There are many things I can talk, but I've heard other experts. They have already covered a lot of this, but I think we need to encourage young scholars like Romit, because I'm sure, it's not an easy thing, because he has spent almost how many years now, about 2 years, 3 years?
4 years.
4 years now. The 4 years of hard work, collecting information, reading books, reading reports, and then coming to what he has done. And I'm sure from here, we will take further steps and try to see, can we create solutions based on what he has done. So I think I congratulate Romit, I congratulate Arna, because you have been guiding him. And I really admire the conversation. I really, it enriched my own understanding. And once again, thanks, Admiral Arora, because you were one person who really helped me open my eyes on underwater domain awareness, because hydrographic survey is nothing but underwater domain awareness. But I think it would be appropriate to tell us that there are hundreds of such aspects, and they need to be brought together for finding more comprehensive solutions so that the environment stops complaining against us. And right now it's complaining very severely and to the extent of threatening us. If you don't stop, I will come back and hurt you. I'm sure you don't want to be hurt in the process. So with these words, I thank you so much for giving me this chance to say whatever I had to say. Pleasure meeting all of you. Thanks a lot.
Thank you so much, sir. With your permission, sir, I would also announce that we have just finished our handbook, MSP handbook under sir's guidance. Catherine and Shlok have put it together along with Sridhar also has contributed, but it is actually also a collection of different dimensions that kind of populate the entire underwater domain awareness and how MSP has to be taken forward. And sir has really been very deeply involved in that book. It is now gone to the publisher. They're working on it, and hopefully in a couple of months that should be out. The second important work that our team is also working, including Romit, is the gap analysis and the position paper. There also sir has guided us significantly. So in that we have looked at like what Dr. Amit had mentioned, we are looking at a specific geography, a specific aspect and a specific application. So like if we take Konkan coast, then we deal with coastal erosion as one area, or if we look at some other Brahmaputra basin, we talk about flooding. So it is very specific to a place rather than being generic. So those are also separately, and Romit has already, he's going to be working on 12 aspects, which can be, again, like if we have done it for the Konkan coast, same gap analysis and so gap analysis basically looks at like sediment management, gap analysis will have people, economy, nature. What are the livelihood losses? What are the other socio-economic and socio-cultural aspects and socio-political aspects? Looking at the economy, what are the economic losses or what are the potential impact on economy? And third is the sustainability or the nature part. So that, and then how the position paper will look at what kind of policy intervention, what kind of technology intervention, and what kind of capacity building is required. So such 12 sets Romit is going to finish. He has already done 7 and others are going on. And this, the whole purpose is that suppose we have done it for the Konkan coast, it can be also done for the Trincomalee coast, or it can be done for Mauritius, or it can be done for anything. I mean, the same template can be done across. And when we have a person like Romit who has worked on it for 3 to 4 years, he kind of takes it to the next level. And then these templates can be used by others to kind of work on some specific aspects. I think I'll stop there. Firstly, I must thank everybody, all the senior panelists who have come. And we'll be recording this entire thing is recorded, and it will also be a report will be generated, and we will be sharing with all the participants as well as the esteemed speakers. So thank you so much, and thank you everybody. Yes, sir.
Just, because knowledge itself sometimes is not a solution, but knowledge is absolutely essential for creating solutions. So knowledge part sometimes is very boring, and solution is very exciting. But we won't reach the exciting stage unless the knowledge is there. The boring part has to be done. So I'm joining with most of the time, Romit, and I know sometimes we get very bored, but that is how it's done. Thank you very much.
Any last comments from our esteemed panelist? Chandrasekhar sir, we can start with you, sir, if you have any final comments, sir.
The seabed is as much a final frontier as space. So give it the same type of focus.
Absolutely.
Jayaratne sir, any final comments from you, sir?
No. Thank you. And looking forward for further engagements and get enlightenment. Thank you.
Thank you so much. Admiral Arora, sir?
I think the sea and the seabed is more unknown rather than known.
Absolutely.
And I would also acknowledge Ambassador Mudgal, very gracious for those kind words, sir. I think we all can just contribute in whatever little measure in this capacity now that we are in, and to ensure that at least the wheels of technology, science, and its not only the adaptability, but it goes to the right forum in the powers to be, because we have the time, sir. They don't. We have been a part of that. We know we have been doing the operational part, but this is one forum I think I carry back. I think I'm truly enriched by getting so much of views from everybody, and the questions that have been thrown even by Dr. Chandrasekhar. That was for me. It got me thinking that how are we going to overcome and ensure this knowledge is passed to everybody down the corridors. Thank you so much, Commander Das, for having me, and
thank you so much.
thank you so much once again.
Thanks a lot. Thanks, everyone.
Thank you, sir.
Bye-bye.
Bye-bye.
Thank you, Nishta. Great job. Thank you, Shreya, and others at the back end. Thank you, everyone. Thank you, sir. Thank you. Thank you. Good, Romit. Thank you so much.
Thank you, sir. Thank you, everyone.